Thank you so much. Thank you. And welcome back after the lunch. I heard I have also the mission to transport some information, but also to wake you up a little bit after lunch, right? We all get a little bit tired after lunch, so I also have that as an aim to provide something which is a little bit cheerful and hopefully entertaining, but also is providing some information. So I want to give you some insights into industrial remanufacturing. What is that? Why is it done? What are the opportunities? What are the challenges? All right, I'll put that down. All right, okay. And first I want to present myself shortly. So my name is Dr. Robert Casper, but most people call me just Bob. I'm of German and British nationality. I'm since 2018 in Bangkok. I did the last part of my studies also in Bangkok. I was in the international program at Thammasat. But I did my PhD on remanufacturing at Linköping University in Sweden. And probably some of you know the colleague Matthias and Eric. They used to be my PhD supervisors. And Linköping in Sweden is very much focusing on circular economy, and I just can recommend that also as a university contact partner to you if you want to have like future partners in academia in that area. Then now today I'm a lecturer. I'm a lecturer at Chiang Mai University after studying and working at Thammasat and doing lecturing, supply chain, circular economy, operations, research methodology and production controlling, but especially, I also do research. I do a lot of research on sustainable production methods. I do papers, and I'm still assigned for my research topics with Thammasat University, with my old boss, Ruth Banomyong, with whom I work on research on circular economy. And then I will give also my contact details at the very end. And I will also provide you my line contact, but also already now I would be very thankful and grateful if we could connect, if you can also share some questions later, if we can think what we can do in future together to extend circular economy strategies here in that region. I would be more than happy to exchange on that with you. But before we go into the topic, and that's also a little bit an idea to wake up after lunch, is to have a little quiz. A little quiz on remanufacturing, and there is no right or wrong. It's a little bit estimation, and there will be 10 questions. It will be online. You need your mobile phones, so it's a little bit like student time again, right? My students love that also. So we will use, it used to be named quizzes. Right, it got a new name, Wayground, and I will switch now to quizzes, and I would like to ask you to take your mobile phones to scan the QR code and to log in and to follow some questions on remanufacturing, and we got also some prizes for the first 3 participants with the highest result. All right, so please scan the QR code. You don't need to download anything, just scan the QR code, add your name. If you would be kind to not use Thai letters, because that will be difficult to read for me, right? You can use your real name or nickname. You can stay anonymous if you want to, that's no problem. And then we'll see how many people join. If you prefer not to join, that's certainly also possible. But you will not have the chance to gain some beautiful prizes here, sponsored by Tiratai. By the way, the prizes, first 3 prizes is a beautiful remanufactured wooden pallet. But actually, it's not remanufactured. It's recycled. Remanufactured would be a pallet again, and made a clock out of it, right? So, and the first prize is also the clock and the last copy of my dissertation. When I was doing my dissertation, I got 20 copies. That's the last one. So the first prize also gets my dissertation, and the topic is of my dissertation automotive remanufacturing. So ideally, it gets somebody who's interested in that. So how many? 62. Wow, I'm impressed. Everybody joined? Anybody else? Problems? No? I see still people joining. Probably let's wait some seconds more. Probably these are people online as well. Is that possible? Are there online people joining? Right? Because it's a lot. Right, 67 participants. Okay, let's give it another few seconds, but it seems to be everyone, right? 67 participants. That's quite impressive. Okay. Again, the questions you can estimate. You can estimate, and just it's not topics we spoke about, right? So don't worry. Let's start. Each question you got 45 seconds time. According to international standard ISO 887 and British standard BS 887, which statement must be true for a remanufactured product? It must only original OEM parts. It meets or exceeds the performance of a new part. It is cheaper than a new part. It cannot include any new parts. Uses only OEM, meets or exceeds performance, cheaper than new product, cannot include any new products. It's difficult for you to follow me, right? So 2 seconds, quick. All right, so let's have a look. All right, so we got already some winners here. So let's look at first the right answer. So the right answer is, it meets or exceeds the performance of a new product. The standardization says it must meet the performance of the old part or even higher. But it does not need to only use OEM parts. Theoretically, it could be even more expensive than a new part. And certainly, it can include new parts. If you have questions later to this, you can ask. Number 2, in typical automotive engine remanufacturing, what percentage of material by weight is commonly reused? 20 to 40%, 45 to 60%, 65 to 95%, 95 to 100%. What percentage of material is reused in engine manufacturing? Percentage of material by weight, 20 to 40, 45 by 60, 65 by 95, 95 by 100. How much material can be reused? Something not working with you? For everyone not working? Okay, there seems to be some people having technical problem, but not everybody, right? Some work, some don't. Let's look for the next question. Actually, probably the internet is like a little bit, right? Probably too many people logged in. Okay, let's look at the good answer. So we have only 2 answers, right? This is strange, right? So in average, it is the 65 to 95%, right? By weight can be reused. That's strange why this didn't work now. I hope that the next question will be working. Let's try. Let's see. Can you see it now on your screen? I don't understand. What I can do now, I can restart the game. That's actually not, but that wouldn't be good. You cannot answer, right? You do not see the question? It says I haven't started. It's probably too many people, right? So some people answered, I see. Okay, let's try to start new. I'm sorry for that. I didn't have that before, but I never had 70 students joining, to be honest. Teacher paste. Sorry for that. Let's give it another try, hoping that it works now. I'm sorry for that. Can you join? Is that working now? Yeah? Oh, we have another Bob, or is it me? Who's Bob? Okay. Good. Let's hope that it works now. 52, 53. Well, at least the first question should be easy now. Okay, 62. 1, 2, 3, 4, and we start. Now it works, but where is it? Is it like, is still at question 3? You see the first question? Okay. So first question again, what according to international standard must be true? Uses original parts, meets or exceeds, cheaper than new part, cannot include new part. So that's an easy one now, right? Ten seconds. All right, okay, very good. So now, okay, the correct answer, B. It must minimum meet the new part standards or even exceed it. Okay, then now let's hope that it moves correctly to number 2. Now you got number 2? You got number 2? Yeah? Good. Okay. Typical automotive and remanufacturing. Percentage of material reused. 20 to 40, 45, 60, 65, 95, 95, 100%. How much material of an engine can I reuse? $55 answered, 56. And this one is not so difficult because actually I gave you already a little help. 64. 2 seconds, 1 second. All right. So, there we are. Okay, 65 to 95% of material, right? Of the, if you would weigh the metal, how many metal can be reused? Okay, very good. Number 3. Now this is a new one. Empirical studies show that remanufacturing an engine compared to new manufacturing can save approximately how much energy? Not material, energy. 10 to 20, 30 to 40, 60 to 80, 90 to 95%. Not talking about material, we're talking about energy now. Okay, K is very white in the front. And the good answer is again 60 to 80%, right? 60 to 80% of energy can be saved. Remanufacturing an internal combustion engine, petrol engine, can reduce CO2 emission by approximately how much compared to new production? So now it's not energy or material, now CO2. 15, 35, 55, 75% of CO2 emission reduced. Okay, who's K? 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 Nobody? Ah. Okay, it's 55. 55% of CO2 emissions. Which factor most strongly influences profitability in engine remanufacturing? What makes remanufacturing of engines profitable? The engine cost per kilowatt, core acceptance rate, number of machining stations, building size. What makes remanufacturing profitable? Energy cost, core acceptance, number of machining stations, building size. Okay, we have a change to BH. But many people say energy cost. Energy cost is in remanufacturing not the most important thing. The most important thing is to have a core part. The core part is the old part which you put into your process and remanufacture and give it a new life. If you have a low acceptance rate, not good core parts, that is not good for your remanufacturing business. So that's the core, the most important thing, the core acceptance, having good cores. Which of the following is most critical uncertainty in remanufacturing? Packaging material, core quality, customer import procedures, warehouse lighting conditions. What brings uncertainty into remanufacturing? Packaging, core quality, customs import, or warehouse lighting? What brings uncertainty into remanufacturing? Very good. So that's kind of is the same story. If you receive core, which is not good, you cannot remanufacture it. But the core, when it comes from your customer, you do not know in which quality it is. So that's uncertainty. It's difficult to plan the core quality before you receive it. So that is a source of uncertainty, right? B. Which design feature increases disassembly time, the time you need to disassemble a part during remanufacturing? Modular sub-assemblies with standardized fasteners, clear material labeling on parts, non-reversible joints must be cut or machined, common torque specifications across models. What makes disassembly longer, increases? So again, some change. Toko, right? Or no, to. It's non-reversible joints. If a part is joined together, for example, welded, and I cannot reopen it because it's not screwed, it's welded, I have extra effort, I have extra work to open it, disassemble it, clean it, and check it. Right? So non-reversible joints is making my disassembly process longer. I think that's question 8, right? Which action is most likely to improve break-even performance for remanufacturing line holding other factors constant? Increase the core acceptance rate through better cleaning and machining processes, add an extra inspection step without changing acceptance criteria, increase the scrap rate, paint casings earlier in the process. So, it was fast, right? That was fast. And it's also a difficult one. Many got it right. Many got it right. Same story again. If I have processes which are leading to more core parts I can use, by better cleaning, by better machining processes, I have more material which I can use, and I need to insert less new material, so that is like increasing my profitability, and I will reach earlier a break-even point in my calculation. We're getting to an end soon. A 200 kilo engine, now some maths, is remanufactured and 70% of its material is reused. How much new material must be added? That's mathematics M1. Who can do it? 200 kilo engine, 70% can be used. How many kilogram must I add? 30, 60, 70, or 140? Who is good in maths? Correct answer is 60, right? 30% from 200 30 from 100 is 30, multiplied by 2 is 60. So 60 kilo of material added, 140 kilo saved. Very good. I think now the last one is coming. Which of the following best support design for remanufacturing in engines? Glue components to prevent loosening during use. Single part closed plastic housing for 100% dust protection. Replaceable wear liners and crankshaft bearing shells. Cast complex one-piece housing to eliminate joints. Which supports remanufacturing? Glue components? Also a difficult one. Let me explain. You want to have as little disassembly effort as possible. So gluing things, you cannot disassemble them, right? So gluing is never good for remanufacturing. Single part closed in plastic, you normally cannot open it without destruction. Not good for remanufacturing. And cost complex, one-piece housing, also very difficult for disassembly. So the best thing is if I have replaceable parts, right? Some replaceable shells, which I can just open from a crankshaft, and I can just easily replace parts. That's the best thing for disassembly. And so now, the big moment, we will see the 3 winners. Do you want to end? Yes. And. All right. First place is, well, we start with 3. First, Mr. or Mrs. Aki, or Aki, where? Or is it online? Aki. Mr. or Mrs. B. And number 3 was, I can't see them now in there. Are they 3 in the room, or might they be online? Where are the 3 winners? Not here? Well, then you don't get prizes. We got one there? No? Nobody of you here? Well, then we'll use the prizes differently. Okay, good, congratulations. They might be online. Is that possible? They might be online. Okay, they might be online. Okay, now let's go actually to what we want to talk about. No, this was just a little bit introduction to what we talk about today. So let me give that. Okay, topic today is sustainable supply chains. And this is a general thing I like doing with students. It's a general engineering thing. When we talk about things, first we define terms. So that's a question now, we cannot discuss that, right? But this is the first question I give to my students. Hey students, you always hear the word sustainable. We all want to be sustainable. Thailand wants to be sustainable. Toyota wants to be sustainable. This is a buzzword, everybody using it. But do we really know what is sustainable? What does it mean? We need to define the term, right? And then, after we discuss that, I come with some definitions, giving some different perspectives, right? So maintaining well-being over a long, perhaps even indefinite period. Or sustainability is defined as meeting present needs without compromising future generations, without having negative impact on future generations. Ability to meet their own needs. Sustainability is by definition orientated towards the future. An ethic of sustainability must take into account the relation between present and future. So it has something to do not only with the environment, with green energy, it has something to do with the action I do today, and understanding the actions I do today has a direct consequence of what's happening tomorrow. That is sustainability. And then I tell the students also, it's not only related to the environment. Sustainability has direct effects on social impact and as well on the economy. And then I go into a little thinking, and I ask the students, and it might not work perfectly for you because we are a little bit older than my students. My students are 18, 19, 20 years old, right? They're young bachelor students, just coming from high school. I tell them, think of how the mobile phone of your grandparents looked like. And then think of how the phone of your parents looked like. It's probably our phone when we were young. Look at the phone you are using today. Look at what kind of cars your grandparents were using. Look at what kind of cars your parents use, what kind of cars you have nowadays. Look at what houses your grandparents had, what houses your parents have, and how we are living today if we look out of the window. And the students ideally understand that something has changed. The standard of living has changed. Which is good, right? We are happy that we might have a better life than our grandparents and our parents. But this has a consequence. Let's look back to the definition of sustainability. Our actions from today have a direct positive or negative influence on the future. This is a very graphic, simple overview of material consumption, key material consumption, and the main inventions of periods. And that symbolizes a little bit the graphic we saw before. Understanding this is increase of standard of living, but with certain impact. Or we could also symbolize it like this. This is the material consumption from 1900 till 2020. And we see several things here. The different the different colored lines are different materials. Let's not go into details. This is material consumption. And we see a little red line. This is the lower line. That is the world population. And we see a purple line, the higher one. That's GDP. So we see several things here. Population grew, but GDP grew faster. And with GDP, also the material consumption grew roughly in the same speed. So we can say that with the growth of the economy, with the increase of standard of living, also our material consumption grew and still grows. Which is nice. Again, we are happy that we have a better life than our parents and have a better life than our grandparents. But economic growth is a nice thing, but it comes with consequences. Let's again say, our actions have impact on the future. So, economic growth with the equivalent growth of material consumption also leads to more waste, to pollution, to environmental damages, to wars on raw material, to pollution of our sea, and to poverty. Sustainability, our actions have impact. And then some thinking changed. In the 1970s, some people understood that's not a way how we can do businesses. That's not a way how we can live life, right? Every year, we increase the economy, we raise the standard of living, we consume more, but every year we also use up more material resources. And this is a classical understanding of a supply chain, a linear supply chain. And this, I took it from an actual book, so like a school book from 2023. So it's not very old understanding. The entire system of producing and delivering a product or service, from sourcing the raw material to the final delivery of the product or service to end users. Very common understanding of supply chain, as we always teach it at university also. This definition has one key problem, because it ends at a point where it should not end. Delivery of the product or service to end users. This is not the end of a life cycle. So normally it should be, at least after consumption, the part must go somewhere. There's waste. After consumption is waste. And the classical concept up to the 70s was, with the waste, either we put it on landfill and forget about it, or we burn it. These were the concepts, right? So that is a little bit an extended linear supply chain. So this supply chain thinking actually of the 70s, take it, make it, use it, and waste it, was a little bit narrow-minded. Right? It forgot something. And then in the 70s, 80s, recycling came up, where people tried to give products, actually not products, but give material a second life. Collect them and think how we can recycle the material and make something new out of it. And later, circular economy, where I come now to, went one step further. Recycling is not the only way to find a closed loop supply chain. Let me go back. Linear supply chain, no loop. There's nothing going back, right? But to close the supply chain. And this was the model from 2000 probably, closed loop supply chain, the first time those terms have been used. And these are common ways how to close the circle, right? We see again the supply chain on the top by reusing from waste to user is reuse, or from waste back to the industry, remanufacturing, or from waste back to the material transformation, recycling. So these are the three main concepts how to gain a closed loop supply chain. I skipped now a little bit the definitions. I think we are all on one page. What's the overall idea, right? Because it aims, and this is the graphic we saw already, it aims at one thing. Material consumption, GDP, grows 1-to-1. One more consumption, one more material use. It's aiming to decouple. Decouple means like to cut the link. We want to stop that I grow here and grow there at the same time. That's called decoupling. So what we can have is the material use here in purple and the economic growth, economic activity in blue. If the resource use is smaller, it's decoupled. That is one aim. And that graphic actually makes it clearer. We are actually in status 1. We don't have a real decoupling. Means we have an economic growth where the resources are spent in the same speed as the economy grows. If we have an economy where the economy grows, but the material consumption increases slower, it's a relative decoupling. If we have economic growth and the material consumption goes even down, that would be an absolute decoupling. And that would be the overall aim, right? We still have an increase of standard of living. We still have a growing economy, but we use less and less material. But this is a future, right? So we are here in status 1 still, right? We are dreaming of number 2, and number 3 would be like something which hopefully one day will be gained. So what kind of advantages does circular economy have? It has many, I can tell. I look onto the clock. I go a little bit fast because I want to give you a practical example. So I go a little bit fast. Again, circular economy is not only green business. It's not only thinking of the environment. It has different perspectives. And we just had a discussion outside. One thing is important. At the end of the day, people will only decide for environmental friendly options. Companies will only decide to set up closed-loop businesses if also the economic perspective is working. Because we all will say, okay, we are very ethical, right? We always take green options. But when it comes to the decision that you have 2 products, often consumers take the cheaper one and not the greener one. So both must be given. So there must be economic advantages, environmental advantages. It must be green, less material, less pollution, less emission, what we heard also in the quiz, right? Harming the environment less and supporting all our political aims to have like a sustainable business or society. But at the same time, and that is possible, and we will look at some of those examples, there should be cost saving, because if I use less material, it should be cheaper. If I can reuse material, it should be cheaper than the new part. But what is happening, we all know if we look, for example, on recycled plastic, and we look onto the market of recycled plastic as of today is more expensive than the same quality of new material. So guess what the industry is buying? But it's possible, right? It's because we have advantages. If I generate less waste, I also have less cost to dispose that waste. I can be more improved, I can be more profitable if I use the resources efficiently, and so on and so on. I don't go too deep, but at the end of the day, it must be a business also. And there are business opportunities for reuse. And there are many examples in different industries, for example, where we have companies renting out machines, forklifters. They bring them back to their own company, repair them, and sell them again or lease them again, right? We have a lot of business, and we will look into remanufacturing or refurbishing. Car manufacturers bringing the parts back from the market, making sure they don't go into a black market or gray market, collecting the products, investing, but then having also a new business. Same exists for IT devices, notebooks, smartphones, often in leasing contracts with companies. They get them back anyway, right? And with little effort can refurbish them and resell them again. And certainly also recycling. Why is coming recycling at the end? Remanufacturing and recycling are two different things, right? Remember closing the circle. The recycling is one way to close the circle, but recycling is breaking down the product into its raw material and then making something new out of it. From the value creation, from gaining the initial value, remanufacturing and reuse is better than recycling. All right, so recycling is done, and this is good, but just like when it comes to what kind of energy is inserted into the process, it's the one where you need to add most effort again. I skipped that, too deep. Some download for you. I have a lot of reports on closed-loop supply chain. I have some international standards in there. I have strategies, how to implement it in different markets. You're welcome to download that. And also, if you have something you want to share with me, please give it to me. I collect always things like that and like to share it, because publications in that area is not for supply chain management. There are hundreds of thousands of books on this, is not so much. Then, that's the concept again. So I also teach about reuse and recycling, but today we are focused on remanufacturing, and I want to give you some practical information on remanufacturing also. So what is remanufacturing? And we had it also in the quiz. Remanufacturing is a procedure of bringing used products to like new functional status with a matching warranty. Or remanufacturing refers to an industrial process in which used products are transformed into remanufactured products with a quality condition that is typically as good as new. Remanufacturing is a standardized industrial process which cores, that's the old part, are returned same as new or better condition and performance. So summary. It's an industrial process. It's not like a little shop on the corner repairing something and say, here we got a remanufactured engine or something. It goes back normally to the OEM, to the original company. A remanufactured Toyota motor goes back to Toyota. They do it, right? Or Apple is doing their refurbished phones. But there are also independent companies doing it. It must meet all standards, all technical standards of the new part, and it must be warranty. It must have warranty. That's so the summary of all different definitions. Different to recycling, I said that already. Recycling is breaking it down into the material. But remanufactured engine is still a remanufactured engine, right? The engine stays an engine. The phone stays a phone. That from material consumption, from gaining the initial value, has a better impact than breaking it down into its components. So how does a typical process of automotive remanufacturing look like? Reverse logistic, meaning the part comes back to the company, we have a visual inspection, And we have this first time scrap for parts which cannot be remanufactured, for wear parts which directly are scrapped. The part is disassembled. Again, in the disassembly process, certain parts are always scrapped. For example, joints, gaskets, ceilings, and something like that. The parts are cleaned in a technical process, and then the big inspection is coming. Do the parts still meet technical standards? If not, scrap. Then machining. Machining, I have some videos of how the parts are machined. And assembly. As we scrapped certain parts, the wear parts and also the parts out of spec, we need to enter some new parts. Testing process, forward logistics. Goes again to the customer. And ideally, the forward logistic is kicking off a new reverse logistic because the customer had an old engine there, right? He has a reason to change. Picking up the old engine, that's the new core part for the next business, right? Let's not forget, no core, no reman. So this is just like showing a little bit when the demand comes. Like normally the demand for spare parts and reman parts come after the sales of a new part. There's a certain delay. It's not so important for today. Let's look into some practical. That's the circle. I don't repeat it. I give some pictures of a company. I was doing an internship for some months, an engine remanufacturer in Germany. Core part reception coming from the dealer. The dealer sends the part. Part first inspection. For parts which they are not remanufacturable, I don't need to clean and disassemble them, right? Directly scrap. Then disassembly into all kinds of components. Technical cleaning processes depending on what kind of material has been used. Machining, here drilling and honing of cylinder liners. We look more at that. Then final assembly line, inserting the new parts. Hot test bench. Testing, shipping. Let's look in some components. That's the upper surface of a four-cylinder cylinder head. And you see it's a normal usage, right? Everybody who was working on cars, right, on your old car probably, that's how a cylinder block looks like, right? But it has hardly any wear and tear. And so the surface is worked, surface grinding. So you lower the height of the cylinder by probably 1 millimeter. So you need a thicker cylinder head gasket. They are available, right? You just have a thicker gasket and it comes to the same result. And you see the picture on the right. Afterwards, it got the same technical specifications as the new part. Crankshaft. Don't ask me why that music is there. It's so relaxing, right? But it's probably so relaxing process. So crankshaft, right, where the piston is attached, and we have the bearing parts here. We have wear and tear there. So there we must have a grinding process, and again before and after. And as we take away metal, it's thinner. Then we need to have a crankshaft bearing with a higher size, and we come back again to the original size. Sandblasting of components, very easy and comes to good results. Remanufacturing of components, here the generator. Here an example of an industrial engine from Deutz. You can buy gasket sets. In these gasket sets, all the wear parts are in one set. Piston set, piston rings, piston pins, bearings, and then assemble again as a new part. And you see here directly why we can save so much material. The vast majority of material of the engine has not been changed, right? And that's the reason we save material. And because we save material with metals, we save energy, right? Because melting that down, that engine, and then having like the raw metal again, melting it again to mold it into something new is like bringing new energy, is taking more energy. Remanufactured brake calipers, that's a brake caliper, but also a brake caliper has very few wear and tear parts. Actually, only those are wear and tear parts. All the other parts can be cleaned, tested, and reused, and just insert these minor parts and then have a remanufactured brake caliper, which then look like this. Old part left, new part right, or not new part, old part left, remanufactured part right, old part left, remanufactured part. Then we know what's happening in the automotive industry, 10 minutes, right? Is that true? It's true. Is a new part, right? So that changes everything. Remanufacturing of car parts is not new. It exists since 50, 60, 70 years, right? And now we got new products, we got batteries, and with batteries, all the old parts, all the combustion parts, turbocharger, gearbox, combustion engine, turbocharger, they all are not needed anymore. We have very few turning parts, especially the electrical motor. Electrical motors have significantly less wear and tear than a combustion engine. So actually the part which needs remanufacturing is the battery. And we are still very much in the beginning of that. And this is a research I did with my colleague Ruth Banom-Yong. We looked at the Thai automotive industry, but these are information from 2023, 2024. So there might be some changes. So we looked at all companies. What are they building? Are they building EVs? Are they building BEVs? Are they building hybrid cars? Where do they build the battery? And especially, do they have battery recycling? So status 2024, there's no Thai company. And we asked them, all are thinking of it. Right? So because, let's again not forget, sustainable, your actions from today have an impact on the future. We especially are implementing BEV cars because we want to be more sustainable. But where do you stop the thinking? Again, think of the old supply chain concept. Do I stop thinking in my consumption, or do I also think about the waste? And this is a little bit in the process of just starting for EVs, that companies also start, hey, what do we do with all the old batteries? Because they will come, right? The cars are now on the road, but after 6, 7, 8, 9 years, all the batteries will come. The first come now, but there will be a wave of batteries coming, and I'm not sure if all companies, not only in Thailand, but all over the world, are prepared for that. But that is ramping up. Remanufacturing for batteries, it's existing and technically possible to do. I go quick to show as much as possible. Remanufacturing of tires, old business, right? You grind the old surface. The tire itself has not so much wear and tear, just the surface which is in contact to the street. So you separate these two things and you mold a new surface on top. It's not so much for car tires important, but for expensive tires for trucks or tractors or something like that, for industry tires of high importance and exist. So we have remanufactured engines, turbochargers, starters, generators, gearboxes, and AC conditioners, and more. These are established businesses, and it's running, right? Depending on the market, they have a high market relevance or low. In Asian countries, rather low, which has something to do, which is important, perception. How do people think about remanufacturing, right? Do you see it as lower quality and cheap, or do you see it as a good opportunity and comparable to a new part? Consumer goods, quickly. Electric toothbrush has hardly any wear and tear, adding some new sealings, cleaning process, and then it's important, and we can hand over to the design. Some have a good design, and I can open them, and I can change what I need to change, and some I cannot open without destroying the housing. And this is also something from the quiz. A key process in remanufacturing is disassembly. If you cannot disassemble a part, you cannot remanufacture it. So, and this is something what design for remanufacturing is thinking of. If you only think to consumption, you don't think about disassembly. But if you also think in the design process that probably one day these parts need to be disassembled, then that might make sense and you think further than just to the consumption. Remanufactured notebooks, we had that, just adding a new memory, new battery, probably some updates, and they are sold on the same line. You can go to the Acer or Lenovo website and you can look, they call it most often refurbished notebooks. Phones, you can go to the Apple site. Apple is selling on their website refurbished phones, full warranty. You can buy roughly 60% of the original price, full warranty. But we also have investment goods, copy machines, 5 minutes. Copy machines or toners, and this is a video, but it's 2 minutes long. Well, I only have 5 minutes. No, we skipped that. It's about medical devices. Medical devices also very important. Here we see it on the left-hand side, high value and many updates, high standards, and scrapping something like that after 2-3 years would be a mess. So they were also brought back to the industry, robots, airplane parts, also furniture. Furniture has certain parts with wear and tear, the top, but some other parts don't. And what I just said, design for remanufacturing. Some manufacturers think very early that these parts probably are refurbished or remanufactured, some less. Some, and this is an initiative in Europe and in America, right to repair. We should have a right to repair. Why? That should be like a normal thing, right? But this is what does the director say? In spirit of the rapidly growing problem of electronic waste, the number of these companies, and he means the manufacturer, right? Lenovo, Apple, these companies are unfairly restricting access to the tools and information needed to repair the devices or actively lobbying against the right to repair. Why do they do that? Because they still earn more money with selling the new part. Right? So probably the older one of you, including me, can still remember that we had phones where we can change the battery. The famous Nokia, right? We just open it and put the battery inside, right? Why do I need to throw away a phone because the battery is not working anymore? And these are now initiatives coming where we say, okay, that is normally a standard thing. The companies must think of something like that in the design process and must make it feasible that such a product is also repaired, either by the company or by independent companies. So what are the roadblocks for efficient remanufacturing? Technical things. There are no spare parts, there are no machining, there are no standardizations. We cannot disassemble the part. We don't have the testing equipment or knowledge to do it. Economic. Remanufactured parts are always in competition to the new part. The nicest remanufactured part will not be bought if it's more pricey, if it's more expensive than the new part. Legal, regulatory, certain things sometimes are not allowed to remanufacture now, or the companies are not allowing it. They are blocking potential independent remanufacturers to do it. Market consumer, probably the market doesn't want remanufactured parts. Yeah, this is an issue in Asian country where remanufacturing has a rather negative perception. Then the people don't buy it. And as I mentioned, design for remanufacturing is like trying in the design process of the part to create a design which makes remanufacturing possible or easier. And this is something which I would like to give you at the end, is a reman checklist. It's a checklist asking several things if Riemann might be suitable for your market, for your company, for your product, and is asking certain things. For example, is the market potential there? Does that make sense to build up such a business? Are there supplies for replacement part? Are there supplies for testing equipment? Is the information there? Do I have reverse logistic? Let's not forget, no core part, no Riemann, right? You need the basis for Riemann. This is a full dissertation. We have the checklist is inside and explained. You can download it here for free. Then, last information. I think I have another 5 minutes. It's a little reserve. I do workshops like this. So what I was talking now, closed loop supply chain, normally is 1 semester for me, right? So I have like 15 weeks time with my students. So that was now very, very compromised. And there's also, I talk about reuse and recycling, but I also make like workshops with my students on closed loop supply chain remanufacturing. My students love it, yeah, because they practically understand what we are doing and why we are doing it there. And then they design their own remanufactured products, and actually a very nice way to learn and to motivate people and to change the perception. If people know what is the advantage and they know and understand and trust a product, they will buy it. So what I can offer you, I would be happy if I can support you in any future form, for example with workshops on Riemann, courses on closed loop supply chain or Riemann, some joint research, or any other topic related to that. And then, as I promised you, again, at the end, my contact details. You are very welcome to link with me on LinkedIn. Stay in contact, ask questions, exchange, come with ideas what we can do in future. And also I have a Line account, you'll find that here. So, do you have any questions? I know there will be like a translation or summary also in Thai. Good luck in summarizing that now in Thai. Do you have questions before? Anything? Arai godai? Nothing? Come on, you can. Challenge me. Nothing? Okay, if you have question or comment or anything you want to share, anything I can share with you, I got also a lot of documents on remanufacturing, just contact me, write me, and I'm happy to share that with you. All right, then from my side, thank you so much and have a great seminar. I think you're on a good path. You can hear, hopefully, that I really like closed loop supply chain. It's not like I have some subjects, right? If I'm teaching calculus, I do it, right? But I don't love it. But closed loop supply chain is something very practical. It's something very nice. It has a direct impact. Let's not forget the definition of sustainability. What we do today has an effect on tomorrow. So, and I think what you are doing here today, the topic from today, has an impact on tomorrow. So I think you're on a very good path here, and you can be happy and proud to do that. All right, thank you so much.